sides in the AM. This is Mark Newman.
Thank you, Newman. Okay. So, after single replacement reactions, we move on logically to double. The next page. Ready with me? Good. So with double replacement, the ions of each reactant switches place. One of three things must happen. Otherwise, the reaction will just put N on, no reaction. Either a gas is formed, water is formed, which is a pure liquid, not a, because it isn't, or a solid. We use the word precipitate to mean solid. Okay. So the general form, you'll see I have blue here. You can think of it as either the blue or the black switching places, but see how A and D basically switch places, it's double. Whereas the other single replacement, you have a single item, pop it in. This is switching part. Since we're all in the same spot, since the state of matter is important, we must indicate the state of matter for all of the chemicals in a double replacement reaction. This is an expectation. What I'm talking about is little AQs. You can assume they happen in water. That's why it's aqua, aqueous. And so on. Let's take a look at a few examples, A, B, C. A gas is formed. Here's an example. Sodium sulfide plus hydrochloric acid. Sodium chloride, but the important thing is that this gas is H2S. You might have heard of H2S. Have you ever heard of someone who, say, works on the rigs getting an H2S certification or anything like that? Poisonous gas. When you drill for oil and stuff like this, there's sometimes pockets where we can't hear the release the gas, put on a gas mask. That's why sometimes people with jobs where they have a potential hazard where they have to put on a gas mask, possibly, once in a blue moon. But they can't grow beards and stuff like this because they have to have a perfect seal. Anyways, underneath this all, say you're not going to have to predict the products of gas form double replacement. Okay. So there we go. But do you notice that essentially hydrogen and sodium just switch places? That's why it's double replacement. Water is formed. These ones are easy to see. Water's going to be formed because an H and a Ca switch places. But when this H goes over here, you have H and then OH, H2O. I like writing it as HOH often. It's easier to balance and you think of something a little different. Think of water as hydrogen ion mixed with hydroxide. You can write it as H2O. There's a reason why I do it. So, easier to balance. Either formula is correct, but whether you use HOH or H2O, I don't care. You'll see me use it interchangeably. And then the third type, the one we're really going to concentrate on, C, precipitate is one, a solid. So, the sodium and the silver switch places. And it so happens that silver iodide is a solid. Sodium nitrate is a but there is a solid. How do we do this? Well, we have solubility chart to predict the precipitate. Here it is in your notes, but I'm going to hand it out to you because it's just like your iron sheet. You're going to have that just sort of side by side when you do assignments. And on a test, you'll never have to memorize this chart, just like you don't have to memorize the periodic. And okay, on this single sheet, I just handed out to you. You might want to write something down. Write down this. Soluble aqueous. Maybe just put it up here at the top. Here. Low solubility salt. Okay? Just that's the way we're going to. Well, we're practicing. But in your notes, which also have it as a separate thing. Keep it with your periodic table. continue using this. More about that, well, try to use it right away. See how it works. So the first thing, use the solubility chart to determine if the compound is solid or aqueous. So, low solubility or soluble. And we'll translate that to AQ, aqueous, dissolves in water, or solid. I'm going to just pull out this chart. That's why your photocopy of the notes. Everybody's flipped to this page, right? Using solubility chart to flip through. Good. Right. So this is what we're working with. Now I've moved my sheet in front of me. Right? We'll look at the examples and then you'll try these stuff. I thought I'd give an example with the same cation in H1. I'll just raise an update. Okay. Now, how does this chart work? Because that's what this is all about. So, when you use this chart, generally look up the negative, the anion. So that's the second thing on a compound if it's written out wrong. Cl2, well, Cl is the ion. So I looked through this chart. Whoa, okay, finally found it. It's in this sixth category, chloride ion. You'll notice bromide and iodide, same reaction. And in this category, I'm going to look and see what barium. Barium is 2+ if you look it up on the chart. It's in the second column. Anyways, so chloride ion, I looked through this list of exceptions to the rule. Barium isn't in. So it must be one of the others with a soluble. What does soluble mean? We said it meant aqueous. It dissolves in water. Have you ever heard of the term, like outside of science, water soluble or something like that? Yeah. Dissolves in water, that's what it means. For example, cooking oil doesn't dissolve in water, right? Whereas you know that salt is NaCl. Readily, it's very salt. Okay, anyways. So we looked that up. We saw that it was soluble. So we're going to write in a little a. You've noticed these before, right? I didn't have to write them in. But that means aqua. Dissolves in water. So we're going to try the next one. Barium, but with sulfate this time. So I looked through my negative ion list. Finally, okay, the seventh category, sulfate. Here it is. Barium is in this rule here. All others, nope, not that one. So barium is low solubility when it's mixed with sulfate. So I'm going to put in S for sulfate. That's the little symbol there. Carbonate and sulfur. Okay, so carbonate. Tenth category, shared with phosphate or sulfite, same compounds in the salt. I'm looking for barium. Nope, it's not in that. It's one of the others. Basically, anything else on the periodic table. Low solubility. I'm going to put an S for salt. And the last one here, barium sulfide. That's my eighth category, sulfide. I look carefully here. Nope. Nope, nope, nope. Yep. There it is. It is soluble. It's one of these. So I go to there and put down aqueous. All right. So I'll mention, you always look up the negative essentially. Almost always. But you'll notice the first three things just have rules that say pretty about any negative mixed with. Basically, these are all, with the hydrogen, anything from column 1. And if you look at column 1, it starts with H plus ion, lithium ion, sodium ion, potassium, and so on. They're always soluble. So if you mix sodium with anything, just assume it's soluble. And then this positive cation, the only one we use, ammonium ion, is always soluble, okay? For anything we do in create a lot of energy. Okay? Otherwise, though, you're going to have to look up. And, well, that's what you're just going to do right now. It's your turn. So, try these 6. I'm going to give you some time. And we'll take them up together. Okay? Let's double check, because you guys, we're taking a side trip right now so that we can do double replacement reactions. We need this skill. So, hydroxide, sodium hydroxide. You could have done this one of 2 ways. But I look up the hydroxide and see that sodium is listed here as salt. So I'm going to put in 8. I said one of 2 ways. The other way was remembering that all those column 1 elements, sodium is almost always is soil. So that's the other way. Most things aren't group 1. NH4, ammonium, mixed with the acetate ion. Now I look at acetate. Silver is the only thing that is low solubility. Everything else. The other way is saying anything pretty well mixed with ammonium is soil. So AQ, once again. How about the sulfate? Calcium sulfate. So I look at the sulfate category. Hey, calcium happens to be the first thing listed. Low solubility, that means it's a salt. So, there we go. Copper chloride. Now we have to be careful. There's 2 types of copper. If you look. There's copper 1 and there's copper 2. And this is why I have D and E side by side. So let's just quickly think about it and figure this out. You can't just look at copper and say it's 1 or it's 2. You have to look at the anion it's mixed with. I'm going to just do some scratch work on it. Well, I know that chlorine is a -1. I'm going to do D and E at the same time. Now, if there's on E, if there's 1 copper and 1 chlorine, and they add up to 0, what does that mean in E? The copper's charge must be 1. So I'm going to write this down underneath as my scratch. Okay? Then the other one, if you think of it as uncrisscrossing or whatever you want to think of, like when I say uncrisscrossing, 2 and 1 negative over there. Either way, or if you think of the charges adding to 0, this has to be copper with a 2 charge. Now I'm going to try this DN. So, chloride, bromide, iodide, all the same category. You notice that yes, it has copper ion, but it's only the copper 1 ion that's low solubility. Copper 2 ion belongs to the others. It's soluble, right? So, copper 2 is aqueous. Copper 1 is the low solubility. So read the chart carefully. Sometimes you have to go backwards. Now, sodium carbonate. I can think of it one of 2 ways. I can think of, first of all, if it's sodium, it's one of those group 1 elements, it's never going to, it's going to be aqueous. It's never going to form. But if I look at the carbonate rule, I'll get the same result. Carbonate, yep. Sodium is listed here, soluble, just like the other way. Okay, I'm going to put that in as aqueous. Active, dissolved in water. Doesn't form a solid. That is 3 different ways. Okay, so why do we need this? Well, you got to predict the following reactions. If there is a reaction, balance the equation. So what I have to do, line chart ready. I'm just getting my line chart out. And finally back to the double replacement. I have to look up this charge. If I look on the table, it has 3 or 5, but I can tell because of this, the nitrate's -1. So if I uncrisscross, the bismuth must be +3. So I'm just going to this here, and I'm going to just put this 3+. This is scratch notes. If I put it in green right now, it's just like something I'm doing to figure things out. Up top, I put out that this is NO3 with a negative. I'm just doing some scratch notes up and above, or below and above. Sodium, I've seen that a few times. So Na+. OH hydroxide is negative. The reason why I'm thinking that, you don't explicitly have to write it out, but I suggest you do it in the margin or up or above or below or something. Is this is double replacement. So I'm thinking that the bismuth, the positive, and the sodium will trade spots. Right? So on the right-hand side, I'm going to, I'll use red because it's in our classroom. I will write to the editors of Harper's Bazaar and tell them what their article is. I told you this morning. Actually, I think I changed the magazine. I forget what I said it was. I'm making this up. No. I think I said Cosmopolitan. Vanity Fair, that's the one. Okay. But I like it. Thanks. So I have sodium positive. Here's what I'm thinking. If sodium, the positive, is mixed with nitrate, right? What's the formula going to be? +1, -1. It's just 1 to 1, right? So I'm going to write it down on the right-hand side. NaNO3. I'm going to leave a bracket here because we're going to figure that out using the chart out. Then, I only did that just so I could get space, plus, and now what I'm thinking is switching spots with the bismuth, 3+. Now, you can't write a formula like it, right? You can't have charges. So, I've got a 3 positive and a 1 negative. I do crisscross them, right? And then I'll have 3 groups of negative OH. I'm going to write that down properly. BiOH 3 times. And then I put a little bracket there. We're going to figure out solid rate. Make sense? Okay. That's why I have my chart here. So I look up nitrate for sodium nitrate. Anything with nitrate that we come across, solid, aqueous. I'm going to write that down in here. Just so it stands out, I'm going to put in AQ. Then I look up the hydroxide. Hydroxide. Bismuth isn't on this list, so it must be an other. Low solubility. That means I'm going to put down solid. That means this reaction occurs. First, I'll write it. If there were 2 aqueous, we'd say no reaction, we wouldn't have to balance. But we have to balance this. balance this. So the green scratch work I'm going to ignore as far as balancing. That was just so I could show you how the ions switch places. So, wow, I look from left to right. Okay. Okay. Okay, back to this. Balance. I've got 3 nitrate groups. I'm not going to think of it as an N and 9 O's. I think of it as NO3 because it stays as arrow. I've got 1 NO3 group here. So I'm going to multiply the front number, you can only balance with front numbers, by 3. Now I've got 3 groups of NO3. But I've screwed up the sodium. I've got 3 sodiums. So I'm going to put 3 on the left side. You go back and forth and make sure it's just right. Hey, now I've got 3 sodiums, but I've also got 3 groups of OH. And it just so happens on the right-hand side, I have 3 groups of OH within the formula. It's balanced. That's how we go about it. Make sense? Well, we'll try the next one. Then you're going to try some. Nickel and acetate switch spots with potassium and salt. So underneath, I'm going to do my scratch, like I did with the other. I'll do it in green. So I know it's nickel, and I know it's a 2+. Acetate, Chiku, is a negative. K, and I'm only writing, even though it's K2, I'm writing down for 1 ion, cation, potassium. So, now, here's what I'm thinking, is that the 2 positives switch places. You can think of it as the 2 negatives switch places, but it works the same. As long as you do 1 for 1. Now, if I make a compound, and I didn't realize that it's stuck together, so I'm going to just do this, and then rewrite it. So attach. This is what I'm making on the other side. This is what I'm thinking, right? Switch places. So let's write it down. I'll get that in red, I'll continue at the same time. K, okay, plus 1 minus 1. So K, CH3, COO. Right. Plus Ni2 plus SO4 2 minus. That's an exact match. So I'm going to just put NiSO4. Then I'm going to look this up. Acetate. Fifth rule, anything other than silver is aqueous. So I'm going to put that in. Sulfate in the nickel. So nickel is not in this category. It's one of the others, and it's soluble. AQ. All this work, and you know what? No reaction. Because one of 3 things has to happen. You form gas, you form liquid water, or you form a solid precipitate. So once I do this, I don't have to do the balancing or anything. I'm going to just write over top of this. Right. No reaction. I'm going to abbreviate. You can put N on, but RXN, whatever. I sometimes use that as reaction. NR is just. So it's done, but you've shown me why there's no reaction. There's no solid. If water forms, yes, H2O or HOH forms. Remember, I'm not going to get you to predict gases. So, your turn. Here's what you're doing. These ones. Finish off for the next 12 minutes. You got enough time to try these. Same method. Go for it.